In this experiment, we'll measure the rate of a chemical reaction, the iodination of acetone. We will attach iodine to acetone in an acidic environment, making sure that the total volume is the same every time and changing the concentrations of each of the reactants to see what effect it has on the rate. In the first experiment, we'll take 10 milliliters of acetone, 10 milliliters of hydrochloric acid, 10 milliliters of iodine, and 20 milliliters of water to make the total volume 50 milliliters. We'll combine the acetone, hydrochloric acid, and water in a flask. The reaction begins when we add the iodine. We start timing the reaction when the iodine is added and continue timing until the solution turns clear. We pour the solution into a test tube and compare it with a test tube that is clear so we know exactly when the reaction is over. The iodine is the limiting reactant here. When it turns clear, all the iodine has reacted. And we can calculate the rate because we know the time it took for that concentration of iodine to react. We repeat the experiment, doubling the amount of acetone, using 20 milliliters. We still use 10 milliliters of hydrochloric acid, 10 milliliters of iodine, and only 10 milliliters of water to keep the total volume still at 50 milliliters. Again, we time the amount of time it takes for all the iodine to react with the acetone. By doubling the concentration of acetone and keeping everything else the same, we can determine the order of reaction in terms of acetone. In a third trial, we change the amount of hydrochloric acid. We go back to our original conditions of 10 milliliters of acetone and 10 milliliters of iodine. We only use 5 milliliters of hydrochloric acid and put water in so that the total volume is maintained at 50 milliliters. In a fourth trial, we change the concentration of iodine to determine the order of reaction of iodine. We must do several calculations to determine the order. First, we must change all the volumes to concentrations. And we must calculate the rate of disappearance of iodine. The order of each reactant is indicated by the exponent following its concentration. We look to compare two trials where a single reactant's concentration is changed. By looking at trials 1 and 2, where the concentration of acetone is doubled, we see that the rate doubles. When the rate doubles, the order of reaction is 1. We call this first order. We compare trials 1 and 3 and see that when the concentration of hydrochloric acid is cut in half, the rate is cut in half, also first order. By comparing trials 1 and 4, we see that the concentration of iodine is cut in half, but the rate doesn't change, indicating that there is no dependence on the iodine concentration. It is zero order. We simplify the final rate equation, getting rid of the ones as exponents. We also eliminate the iodine term since it is zero order. We can calculate K by substituting data into the final rate equation from any one of the trials and solving for K. Notice that we configure the units for K by doing the simple math.